Okay, hello everyone. I'm here with Alan Smith, facilitator with Drops Global. Alan presented and answered many questions about Drops during our webinar on 11 August 2020 on Drops inspections, surveys and audits. Many people reached out to me for a copy of the recording, which we did not make this time. So we're here again to record a presentation and answer several of the questions asked during the meeting for our YouTube channel. If you like this video, have any comments or questions, we look forward to hear from you in the comments below. Alan, welcome. The floor is yours. Please share your screen and start your presentation.
Thank you very much, Joe. I say my name is Alan Smith, and it's a delight to be able to share my presentation with you guys through the Drops Asia forum. This is my first time on Zoom sharing, and I'm hoping that Joe, you can confirm that you can see my presentation on the screen.
It works very well, yes.
Oh, excellent. So here's my name here. Yes, so the first thing I wanted to cover was from the Drops admin team over in the UK, was just a very brief update of where we're at, what we're doing. We are working on some guidance updates as an output from the most recent update to our recommended practice document, the revision 2, which came out earlier in the year. Just some key things on the survey inspection best practice. We want to kind of refocus on the risk ranking element. We want to really make sure we are addressing secondary retention as we should be, clearly defining the difference between secondary retention and safety securing. And of course, the importance of inspecting safety securing too. We'll also share some new examples of templates, which will reflect a number of different approaches across the industry. Reliable securing, some updates there, minor things, mostly to do with new industry guidance. Just as a quick example there, we recommend that gates incorporate a tow board, whereas in industry guidance, that's the recommendation is completely the opposite. In that tow boards on gates can actually cause a hazard, particularly where items can be jammed in grating, stopping gates from opening and closing, etc. Restricted access zones, we're going to update the cone of exposure, plus we've got lots of updates from across the industry on how we've approached things like red zones. Tools and equipment aloft, a new log sheet, the promotion of considering a record of all tools and equipment and every job, making sure that we have that opportunity rather than just relying on the likes of the Derek logbook, is to have documented checklists of what we're taking up, how we're taking it up, how we're bringing it back down again. And also with tool weights, the maximum tool weights that we can secure to ourselves. We're working with Arata on that one. The Drops Train the Trainer program is now online, mostly due to COVID, but that's been very successful. There are a number of dates available on the website. And Drops membership continues to kind of remain at around about 200, 220 members. We're going through the process of updating and renewing subscriptions just now. But what I want to focus on really was, again, this is a key part of all of the Drops campaigning, the Drops promotions, is this principle of addressing that hierarchy of controls. The understanding of the hazard, of course, is important. The ability to assess the potential dropped object is all part of that, being aware and understanding of the hazard. That addressing the hierarchy of controls is, of course, if we can eliminate the item completely, or we can eliminate the dynamic force that could cause the dropped object, that's where we should be starting. Substituting, moving things to lower levels, changing the way we work, that's another opportunity there too. But what I want to focus on in this presentation was the opportunity we have within the control section. Within controls, of course, the most important when it comes to drops is a focus on engineered controls. The competency of our people, the procedures, the admin controls, these are all critical and important, but engineered controls has to be our main focus, particularly when we start thinking about dynamic potential. We need to be able to identify with dynamic potentials, and we need to be able to think about those across all activities at all task stages. One of the examples we use to kind of illustrate this is this picture here, which we grabbed from a petrochemical plant. I won't say where. This is a refueling tank, and it's used to refuel various vehicles, small vehicles and compressors and generators that will be used on site. As you can see, I'm pretty sure from the drops point of view, we'll all be looking at this thinking, I wonder how heavy that is. Even at half full, you know, it's half a ton, that tank. We'll all be thinking about how on earth does it stay up there? We'll be thinking about the static potential, the potential for this to crumble under its own weight. Some of us might even start thinking about things like the center of gravity. Of course, that has an effect. Gravity as a hazard, or is it gravity as a friend? We'll also be looking at the fastenings, you know, the fixings, how the support structure is secured. Is it bolted? Is it screwed? Are there any welded components? We'll be inspecting that too, because we're thinking about you know, how this is actually supporting that load. We're thinking static here. Beyond that, we start thinking dynamic potential. You know, we start thinking about how movement in the environment might affect the load and how things are physically secured. We will be thinking about collisions, perhaps from the vehicles, collisions perhaps from people. But do we actually then think about this through the whole process, the whole life cycle? Do we, for example, ask the question, how does the tank get there in the first place? Is the tank itself an element that is lifted and moved? You know, further investigation shows, yes, that is the case, that's how we actually fill the tank. We pick the tank up, we take it off-site, we fill it, and we bring it back. Perhaps that's where the dropped object is. Perhaps that's when the dynamic forces take over. So start to consider every task through every step of the way. And in some of the work that we've done with the IOGP and looking at Helidex, it's kind of well highlighted here too. This is an element, an example from a work group where they're looking at an update to the requirements for inspecting Helidex. When it comes to dynamic dropped objects, of course, within the offshore environment, we consider helicopter downdrafts and sidewash as a dynamic force. It's a key part of the reliable securing considerations. Some of the examples that we find from the industry, some of the incidents that have been caused by helicopter downdraft, there are several. This one is particularly interesting because it's something that is designed to be here. It's something that's designed to be secured and hopefully has been designed to withstand helicopter downdraft. However, during routine maintenance, whether it's not been considered or whether it's not been inspected, that the failure to reinstate that securing has caused a dynamic dropped object when the helicopter landed. This one here is, again, poor fixings, not really considering our fixings, fastenings and fixings and repairs, without due respect to the hurricane forces that a helicopter downdraft can cause. An old one from our library of incidents. Again, this is the ability for the helicopter sidewash and downdraft to physically lift a 200-kilo box that was sitting on dunnage and to throw it to the deck below. Again, consideration at the time to put the 200-kilo weight up on the module roof. Well, that's a consideration perhaps for static potential. But do we consider those dynamic forces that could affect it throughout this life cycle? So when it does come to the Helidex inspections, of course, there's a lot more than just looking for the foreign object, the debris, the loose items that can be lifted and thrown around. It's all to start to think about, you know, how all of the elements, all the equipment around the Helidex has been inspected, how it's been installed, how it's being managed. So this work group with IOGP had started to look at perhaps adding some key considerations into that process. They determined that what good looked like was actually the process that Drops has kind of been pushing forward with when it comes to the Drops inspection, the systematic approach to identifying potential dropped objects, recording them, and ensuring them they're inspected on a routine basis. In particular, identifying the engineered controls. So, as a part of that, the recommendation there is that the inspection process would have some new items added. So there is, of course, the requirement for the FOD, the foreign object debris inspection, but also the requirement now for there to be a a consideration of the potential dynamic dropped objects, to consider that dropped object survey and assessment process, to raise more awareness by linking drop safety alerts specific to helicopter downdraft, making sure that the industry is aware of that. And then also then again, as an output from the recommended practice, is to have some form of audit or assessment to ensure that there is awareness across all the teams, particularly in helideck and deck operations, the awareness of dynamic dropped object potential. So where are we at just now? Well, we've developed a shared understanding. We're sharing posters and videos. There are various videos and links available throughout the industry, just again to raise awareness of this. And of course, we urge the industry to share back with us if you have any examples of helideck inspections where you've considered dynamic potential. Please let us know so we can share it back with the industry. Because of course, it's not just oil and gas that will benefit from this. Other industries too, particularly the offshore renewables sector, in fact, anywhere where there's helicopter operations. A recent trip to the Maersk Venturer, we undertook just a more detailed helideck inspection with that key consideration in mind. So this is with the guys doing the inspection prior to the helicopter arriving. We added a few more items. We had a kind of a broader view and started to consider dynamic potential. The one that, well, there's several to highlight, but there's an interesting one which we all typically have around the helideck is a signboard. Having a look at the signboard, particularly within such close vicinity to the helideck, was all of these items are all secured somehow. The sign itself is secured. All of these sign components are secured. If you consider maybe 2 or 3 times every day, for that short space of time, just a few seconds here or there, hurricane force winds blowing at these signs. When we see it on television, when there's been a hurricane force winds ripped through the high street and signs come down, the same principle applies here. So ensuring that we are thinking about beyond just foreign object debris, start to think about the impact of helicopter downdraft on our installations. And around the helideck, start to think about some of the ancillary items, even things like those items that we use on a temporary basis, the halyards on the flag systems, for example. Even gates, hatches, even thinking about the actual fabric of the facility too. Again, thinking about the downdraft, the side wash forces, and what that can do to generate dynamic dropped objects. We do have a very short prompt card which is available online, and again some key points to consider there. Some good points here just to make sure that we are thinking about the funneling effects. We will address things like closing containers and such like on deck, but think about that, the force of funneling effects, how that might affect temporary work or temporary work sets. Likewise, anything that we're going to install, anything new, make sure we're carefully considering the exposure. So if we're adding beacons or communication systems, start to think about how we're securing those, or how we are reducing or even eliminating the exposure from helicopter downdraft. Of course, when it comes to fastening and fixings, reliable securing is our go-to guide, developed by the industry, by specialists. Now at revision 4, we're obviously going into revision 4A or even revision 5, because we're continually learning with this subject. But the fundamentals here are to address, most importantly, secondary retention features. These are small items, they're critical devices, they're designed, they have a purpose, and we need to make sure we're addressing them. When it comes to drops definitions, to be clear where they sit in our definitions, the primary fixings that we identify with are typically the nuts and the bolts and the screws and the clamps and the hinges. It's a preventive measure. It's an engineered control that will retain an item at height particularly. And as we subject it to continual forces, vibration, we must address secondary retention. We must have an engineering device that retains that primary fixing. If it's a number of components, we're going to need things like safety pins. We're going to need things like lock wire. If we're retaining a clamping force or a load in a bolted connection, We're going to need things like locking nuts and locking washers. These are all preventive measures. So these are all appearing as the items that will reduce the likelihood of the component or the equipment coming apart. And also, again, we achieve integrity by addressing this too. If we risk assess and we still require to apply additional controls to reduce the risk further, safety securing is our measure. And safety securing will include a variety of items such as safety wire and connectors, nets and baskets. But bear in mind, these are mitigating measures. Yes, if we've made the right selection, these items will catch the items before they drop to the deck. There's a lot of considerations here, and that's why we're going to readdress this in the survey and inspection guide to make sure that we are focusing on inspection requirements for safety securing. But to highlight the importance of definitions, even our safety securing needs primary fixing and secondary retention, and we'll highlight that later. One of the components we really want to address, and we were addressing this continuously across every region, is the application of split pins or cotter pins. We need to get the definition right there because we call it different things in different industries, but for drops, the split pin is a metal fastener. The split pin is a hardened steel or a stainless steel. A cotter pin is typically a pin of a lower grade, but cotter pins and keys, cotter keys may also refer to split pins in the US. So first thing is also make sure where you are in the world, if you're talking about a split pin in our industry, it's a hardened steel component. The guidance that we have here on all safety pins is quite clear here that if we are supplied with linch pins or roll pins or R-clips or nappy pins, that we must consider the potential for dynamic forces to rip these out. And that's an important focus. If that is the case, if it's OEM supplied, then we need to start to maybe reassess that. And if we need to change, we need to make that change, then we need to manage that carefully. But the key principle is ensuring that these items are not knocked out. The obvious replacement in the event that safety pins could be knocked out would be a split pin, but the split pin must be correctly splayed. So we want to just highlight that by just maybe going back to the basics on the split pin, an understanding of the fundamentals of design, the tines or the prongs. For obvious reasons, these are able to be splayed. The head is the head, and it's an important feature. It needs to be the correct size because this is what's going to stop the pin from falling through the hole. It's all very obvious, but when you start thinking about dynamic forces being applied, that's where this becomes critical, the size of the head. If any forces are applied, the head will crumble, and if it's the correct size, it will not pass through the hole. The selection is critical. The documents that we get with split pins from the split pin manufacturers, have a look at these. That can be very interesting and highlight the need for addressing the right size of pin for the right hole. Just to clarify, nominal diameter is the size of the hole. Therefore, typically the diameter of the split pin is going to be slightly smaller, but the tolerance here is minimal. The size of the head, again, is critical, but you can start to see here that typically the head size can be as almost twice the diameter or the dimension of the actual diameter. And again, that's an important factor to consider. If that head is squashed because of dynamic force, it will not pass through the hole if it's the correct size of pin. The installation is critical. The splaying of the split pin is critical. This diagram has not been developed by Drops. This has been developed by the industry. It is continually referred to, and it's important that we address this, particularly in a dynamic working environment. Splaying of the tines, both tines, gives us the protection that we need. Splaying them correctly ensures that there is no snagging, because snagging can cause the pins to be pushed out, and we'll illustrate that later. Other applications, particularly on crown nuts or castle nuts, the correct application. If you're not sure, always check with the OEM, but typically during maintenance, that's where sometimes we fail. We're not as good as we can be in replacing items to the OEM standard. Knowing where secondary retention is critical, well, that's a really important factor, particularly then if you're thinking about dynamic forces and how our dynamic operations interact with our equipment, especially equipment being used at height. So if we think about an application like lifting and the application of a shackle, we appreciate this picture here shows perhaps not the best arrangement in lifting gear, which is a story for another day, I'm sure. But it does illustrate that if we do not pay attention to our secondary retention, for example, our split pin, if we do not splay it correctly, there is the potential for split pins to be knocked out. And sometimes we can spot these, but sometimes we don't. And then we've lost our secondary retention and we end up with the loss of our primary fixing. This is an example of a safety securing device at height, at the crown, just below the crown level. A safety securing device, which is a safety wire, in response to the perceived risk that the block will, the shiv could become a dropped object. Again, that's a discussion for another session, I'm sure. The focus here is on safety securing devices requiring primary fixing and secondary retention. If we consider this in the scheme of the inspection program, the inspection process, when we address the static potential, we've got to consider our primary fixings, we've got to consider the dynamic potential, we've got to consider moving hinged parts, how things move, we've got to consider the potential for dynamic, for vibration or for snagging. We also consider consequence. When we address all of these potentials, we address those primarily with our preventive measures, the primary fixing and secondary retention. Here we have an example of secondary retention on our shackle. This shackle is part of our safety securing system, but I want to address this component right here. If we think about the dynamic forces in play, if we think about the force being applied on the block itself, the potential for movement in this safety securing device, just slight movement, and even again rotation, perhaps due to vibration of the pin on the shackle, ultimately this split pin will rotate. The potential therefore exists for there to be collision or snagging with other components, causing this to be pushed out. The fact that we have one tine splayed like this will make no difference. The potential for this to be pushed out is right there, staring us in the face. We have a number of incidents whereby we believe that split pins have been forced out or pushed out. So we must be ready and prepared to splay these things correctly. We must also be prepared to start asking the question about robustness of fixes and fittings. Go beyond just the questioning the engineered elements. Start asking about who inspects it, what do they inspect? Is there a preventive maintenance system in place? Who addresses this? Who discusses this? Don't rely on third parties to take care of this for you. We are all responsible. Just as an add-on, this was something that was highlighted during a Saudi webinar just the other day there. Again, some difficult places to reach when it comes to inspections. Of course, we have rope access. We have some specialists that can help us with our inspections. But sometimes there are some difficult to access areas, particularly on drilling equipment, where we cannot physically see the fastenings. The little devices like this, these little bore scopes, they're not that expensive, but they might be just a handy thing to add to your kit. Of course, we haven't yet found one that is suitable for use at height, so I'm sure that there'll be a device available to ensure that this does not become a dropped object, and that it can be secured correctly if it's used at height. Thank you very much for your time. As always, I enjoy talking about this subject, and like you guys, keen to learn, keen to share, and keen to see a point where we can actually say that we've achieved our objectives of eliminating dropped objects from our industry. Thank you very much, Joe.